Hello, everyone. Nice to be here. My name is Oisín Kyne. I'm CTO and co-founder at Obol, and today I'm going to be talking about distributed validators and to specifically give you a bit of a snapshot of where we're at. So, firstly, I'm going to go into the current state of distributed validators in the market, give you an update on where things are. Then I'm going to talk about how DVs impact different segments of the staking, and I'm going to talk about some new announcements we have to make. So this is a pretty staking native audience. I'm not going to dwell too much on what distributed validators are, but a distributed validator is like an Ethereum validator that runs on multiple machines instead of one, and if one machine fails, no big deal, server stays online, your validator stays up. The easiest analogy is to consider it like a multisig for a validator. What's particularly important about this is you don't have to have one single entity running all of the nodes. You can instead have a group of operators running nodes. And we'll see as we go on, this is something that's very important to it. Before I get too into the use cases, though, I do want to, if you'll allow me, talk one bit about the technical side of things and how we've built our implementation of distributed validators as a middleware. So why a middleware? A middleware is something that sits between the validator client and the beacon chain, and most importantly, it doesn't have runtime access to your private keys. It's just simply deciding on what every validator should sign and aggregating the signatures that come back. This is important for a number of reasons, security being top of my list. If anything were to happen to our software, it doesn't have your private keys, shouldn't be able to get you slashed, shouldn't be able to do anything except maybe knock you offline. But it also has, your user experience benefits that you don't have to replace your existing private key infrastructure. You can keep your validator, you can keep your Web3 signer, you can keep your vouch, and you can generally just slot this in as one extra container. And as well as that, the networking side of things, each of these clients are hooked up directly to one another with TCP connections, so you have fast latency between them, and your signatures aren't going over a multi-hop public network where people can kind of eyeball them, disrupt them. So as for where we're at in terms of maturity stage, we are just coming to the end of our alpha phase, where we've had 40 entities and around 40 solo stakers running on mainnet with us. We are currently in the process, as we speak, of deploying the simple DVT module for Lido onto Holski. This will be aiming to almost 5x the operator count within Lido if everything goes to plan. We have spent the last 2 or 3 months at this point running Operation Solo Staker in conjunction with EtherFi. This is getting solo stakers that wouldn't otherwise have the means to run on mainnet, the ability to run DV clusters with one another and get delegation from EtherFi to take part in protecting the network. We've been doing enterprise testing with the likes of Mega Labs from the Barcelona Supercomputer Center, along with some of our other enterprise partners, where we can prove that this software can scale to 5K validators on Gurley to show that this works on the enterprise side of things as well as on the solo sticker side. We've completed a security assessment with Sigma Prime. On Monday, we're kicking off our second audit with Quantstamp, and we've also done an audit of our Solidity, which I'll talk about later on. So that's a quick update as to where we're at in terms of adoption, and now I want to talk a little bit about the use cases and the benefits as we go through the different parts of the market, because not everyone uses DVs for the same reason. So the first I want to talk about is the professional validator side of things. For a professional validator, one of the main benefits of distributed validators is the idea that they can have high availability. High availability is the fancy way of saying, if one of my servers dies, I don't want my whole validator to go offline. Currently, these enterprises often run like an active node and a passive node, and if the first one dies, they turn on the backup. The problem is that if the primary comes back, you get slashed. And of the 99 slashing incidents so far on the network, almost every single one has been from double signing. So instead of having your full private key in 2 different places and praying they don't run at the same time, with distributed validators, all of the different nodes have a piece of the key, about like a third in a 4-node cluster. And the idea being that if you run 2 copies of this by accident, nothing really goes wrong. Monitoring realizes something is a bit misbehaving, but these clusters are Byzantine fault tolerant. You don't get double signed or double slashed, sorry. As well as this, because of that, you can then start to change your ecosystem and your deployment. You can move to bare metal because you couldn't normally run on bare metal as an enterprise, because if your machine died, there was nothing you could do and you were sitting there looking at a dead node. Whereas now you can say, okay, I'll spin up an extra node. If the first one comes back, no problem. This can amount to very significant cost savings for these people, particularly the ones that are running in the cloud and that are struggling with egress costs and vCPU performance. And yeah, they're the main things I want to talk about on the professional side. The other major kind of part of the market is the liquid staking protocols. For a liquid staking protocol, one of the biggest benefits of distributed validators is the idea that different entities can run pieces of the validator. You no longer have to give the full validator private key to one entity and cross your fingers and pray they don't lose it. This is super important for the LSPs that want to become very decentralized, for bringing in more solo stakers and bringing in people with kind of low collateral. You can have much more peace of mind that so long as there's a group of them running and they don't all collude against your protocol, they can't withhold from you, they can't all get, well, if they all lose their keys, you have a risk of slashing, but so long as, only a subset of them do, not the end of the world. And generally speaking, this is how we see the decentralized liquid staking protocols moving forward, getting groups of people to run validators instead of individuals. I've already talked about it, but Lido is one of the main ones. They're looking to bring 0.5% of their stake onto DVs on mainnet early in the next year. A new set of the market that is hopefully something that I would like to see grow over the next few years is the idea of community validators. There are lots of communities within the Ethereum ecosystem, from different parts of the world. Latin America has a super strong community. SheFi is a group of women in crypto. All of these entities have an interest in staking. The vast majority of them don't have, the 32 Ether to stake alone, or even if their DAO has a significant treasury, they can't really just give it to one operator or one member to run it on their behalf. However, with distributed validators, they can set up a cluster amongst their own community, and they can either seek delegation or they can delegate their own Ether to them, and they can keep the rewards within their community, and they can generally grow the pie for themselves and to build a place where they can make the revenue from running validators. As Ethereum needs to decentralize, we don't want a world where the Nakamoto coefficient is 3 or 4 or 5. We want a world where there's hundreds of these entities that are their own small little pools, running their own Ether, controlling their own destiny. This is where I hope the community side of Ethereum goes, where people stake their own Ether on their own nodes in groups. On the token holder front, this is the idea that if you're trying to hold an LST, you want to be pretty sure that it's going to behave. You can sleep better at night knowing that there's a group of people running the validator rather than if you have one specific operator running your LST. I don't know about you, but I wouldn't be as comfortable as that, but that might be because I would have built a validator project before. But last but not least, I want to talk about Ethereum more broadly. So Ethereum itself needs its operator set to be decentralized. It needs the validators to be resilient from client bugs. We have only about 5 clients at the moment, and every now and again something goes wrong. That's just kind of the way it is. If you have a distributed validator cluster where you have different clients in every single node, if there is a failure of one, you shouldn't go offline. This actually happened earlier in the year when Ethereum lost its finality. None of the distributed validators we had in mainnet missed a single attestation because they weren't overly exposed to the clients that had the issue. Ethereum wants to decentralize. It wants groups running validators. It wants not to be controlled by one single protocol. So Ethereum benefits from the idea that groups run validators rather than individuals. So that's a little bit about some of the use cases. And now I'm delighted to be able to talk to you a little bit about our journey. I've been worrying about Ethereum proof of stake since about 2018 when I kind of got to grips with the energy use of proof of work and then started looking into the alternative. We've been working together formally as Obol since early 2021. We deployed our first mainnet validator at the end of 2022. We announced alpha in the middle of this year. And as of today, I'm super thrilled to announce we're now in open permissionless beta for anyone to run coming on the 1st of December. This is the first time we're going to allow generally anyone to run one validator if they so choose and are willing to give it a run and to really kind of grow the amount of people running this software. And more specifically than that, the focus in beta is less about running just one DV, and the focus of alpha was to get people testing and prod, frankly. And with beta, we now have 2 new tools that we're releasing, and we're going to really focus on developers, particularly of liquid staking protocols and any sort of staking project. And those 2 pieces are the SDK and Obol splits. The DV Launchpad, to touch on it briefly, this is our user interface for creating distributed validators. We've taken the approach that you need to know your counterparty in a DV because you're placing a lot of trust in them to work with you. So this is now going to be available for the public for anyone to use capped at 1 validator. And then the Obol SDK is a TypeScript SDK to allow people to provision DVs programmatically behind the UI. So if you're building a staking project, you want to bring DVs in, you'll just use this SDK to propose a cluster. All the operators will create the keys to the kind of spec that you've asked for, to your withdrawal address, to whatever you need, and they will return the deposit status to you, and then your front end can can deposit with the 32 Ether to activate those validators. Coupled with the SDK is something that I'm also very happy with and something that I think is novel in the space, which is our smart contract splitters we know as Obol splits. Obol splits are immutable, non-custodial, and novel to everything else is Oracle-free. Most staking projects today have this kind of dirty little secret of depending on an Oracle to tell them how much Ether's in them. There's even been situations where there's like keys on this Oracle being compromised, and if enough of the keys get compromised, you have an infinite mint bug. This is something I was, not willing to settle on, and have been since about 2020 trying to design something that was permissionless and immutable and Oracle-free. And thanks to the help of the splits.org team, I'm happy to say we have something working. It is entirely pull-based and allows you and your cluster to divide your rewards and principal and fees all programmatically and all pull-only. So I would advise anyone that's into the Solidity side, give them a look, give them a test, and let me know how you get on with them. And last but not least, we have Charon, our software client. We're moving into beta. We're getting a second audit for it, and it's been behaving better than I could possibly have hoped. So I'm thrilled with that. So I'm coming up to the end. I want to conclude with the idea that staking doesn't have to be run by individuals, particularly in a world where you're kind of delegating stake to others. I'm a firm believer that validators should be run by groups because I think groups are harder to compromise than individuals. If there's a scenario where it's like, oh, defect, do something weird with this validator, censor this person, if you have to kind of coordinate with your full group of 6 other operators to be like, hey, we should do this sketchy thing, it's a lot harder of a sell than to do it if you have total control. And even when it comes to private key loss, people lose private keys, people get key loggers, it happens to so many people in the ecosystem. You do not want your validator to become slashed and compromised because somebody clicked on a dodgy PDF or got a dodgy MetaMask extension. So I hope over the next year we move in a world where validators are run by groups, and this idea has more been popularized by the Bankless crew is squad staking. I'm hoping that people will find their squads, people will set up validators, we'll have smaller groups of people all working together, running validators, making kind of a cut of the rewards for it, and that Ethereum is run by groups, not individuals. That's more or less everything for me. I don't think we're actually doing any questions, so I'd like to thank you all for your time. And if you want to find anything, we'll be outside in the main hall. You can come chat to us. Thank you very much, everybody.